One of the things that's really made the computer get a lot faster and do some really cool stuff is advances in RAM. And so let's talk about what is RAM. You will see this on the exam, and you probably already know RAM is random access memory. Now, when you turn your computer on, the programs get loaded into random access memory. This is storage that's available as long as the PC has power. Now, anything that we want to save while the PC is powered off, we have to write onto a hard drive, and it's saved in magnetic format. Random access memory is saved in like an electrical format, in the form of little switches having a charge or not having a charge, zeros or ones, going back to our binary. Now, random access memory, or RAM, is considered volatile because once we lose power to it, the information stored there goes away. So when you shut your machine down, the RAM is cleared. It goes away. So it's volatile. Then, technically, it's called DRAM, and that means dynamic random access memory, because we can write to it or read from it dynamically from anything. Now, when you think about RAM, I want you to think storage bins. Just think of a large wall covered with little square boxes, and every time we try to save something, we're going to put information in there. Now, change that even further and think of an entire wall covered with a lot of really small boxes, maybe 1 inch square. And these boxes are arranged in groups of 8, and we're going to put either a 0 or a 1 in every box. And then based on the group of 8, we're going to look at it and look at the binary and determine what's stored there. And so that's a very simplistic way of thinking about what's going on. Now, we haven't talked about this much. I mentioned it previously in the video. The MCC, the memory controller chip. This comes into play with RAM access memory and random access memory, pardon me. I can't think and talk at the same time. Let's talk first of all about early RAM, and we'll talk about the MCC shortly. Early RAM was referred to, if you see the term FPM or fast page mode, they're talking about old RAM there. So watch for trick questions on the exam. This was 8-bit memory. Each chip was 1 bit, and there were 8 chips on the stick, and so this created an 8-bit chip. Now, if you can get a picture of that, and you've seen those RAM sticks before, and there were 8 little squares on there, and that's how we got the 8 bits, or the 1 byte of memory that was passed back and forth to the processor every time. If you remember, the 8088 processor had an 8-bit external data bus. So when they designed the memory, they made it 8-bit, and so it could send chunks of memory to the processor very efficiently. Now, modern RAM, each chip holds more than 1 bit. Okay. Otherwise, we would have these massive memory boards with 400 or 500 chips on there. So they've now changed that up quite a bit. And this MCC, this mysterious thing that I keep talking about, manages the data storage and the chip allocations and who, what, and where. So let's talk about this just a second, this diagram. First of all, the early CPU had an 8-bit external data bus. Notice 1, 2, 3, 4, 5, 6, 7, 8. And so what they did is on a single stick of memory, they simply attached 8 chips, okay, and each one of these could deliver 1 bit. And so then when it became time to pass information to the CPU or read it from the CPU, it simply passed it as a bit on every wire, and so it got a 1 byte or an 8-bit delivery to and from the CPU, and the CPU could access random access memory and write to it. Well, as these things started to get larger, rather than make the chip get larger and larger and larger to add more capacity, they began to add more capacity to the individual chips. And now we had a new issue. The CPU could no longer talk to them because there was more complex addressing on all these chips. There were a whole lot more bins to stick stuff in. And so the MCC, the memory controller chip, now sits between the CPU and the RAM. And this thing is on the motherboard, and the CPU passes requests to the MCC. And the MCC does lookups, and it does some other magic and smoke and mirrors, and it knows where on which one of these chips the information the CPU is. And so it uses those addresses to go request that memory, to pull it down here, put it in the form the CPU needs, to put it on the bus and pass it to the CPU. So that's what the MCC is doing. It's pretty simple in theory. What it's doing is obviously not simple, but that was one of the major changes to the motherboard that allowed our RAM capacities to increase dramatically. And so what we're going to do now is, in the next video, we'll talk about the different types of RAM that are out there and what you're going to encounter on the exam when it comes to RAM.